Right, video number two, we're going to look at our homologous series and our functional groups. So homologous series, we have too much stuff inside. But if we just try and think of everything individually, it gets too much. There's all of the things. So we go homologous series, homo, same, logous, grouping. So we put these groups of things so we can kind of compare, and we can say, well, this group is doing this group is doing this group is doing this. So they have similar structures, similar properties. You know, once they get really big or really small or lots of chains or something, they might change. There's a general formula you can use, and then there's a pattern in the physical properties. So there's a pattern, you know, as you get bigger, it might be more flammable or less flammable, different flash points, you know, different viscosities, all those kind of things are going to change as you go up and down the groups. So we'll start with the simple. I think we did all of these last year. I can't remember. So I'm not going to expect you to remember all of this straight off your head. And you need to do some revision in the holidays to kind of get your head around it again. So we have, and we're just doing them very simply. Then we're going to go into naming. Then we're going to go into properties. Then we're going to go into some of the reactions. That's our kind of building of our knowledge. So, okay. So, alkanes, alkenes, alkynes. I'm going to say it like a weirdo, so it makes it really clear. A, E, Y. So, single bond, double bond, triple bond. Triple bond. So, this is going to have the biggest bond strength, next lower, then a lower. And all of our alkanes will have similar properties. Generally, there'll be that general formula, and there's a pattern in the properties. Same with the alkanes, so that same with the alkynes. Then we have an addition of a functional group to these. So these are our very basics. Oh no, before we did the functional group, we did benzene. Not me. Right, then we have benzene. They only want you to know ring structure. I'm not quite sure why they only. Right. So benzene is when you have 6 carbons. 1, 2, 3. 1, 2, 3, 4. Oh my lord. 1, 2, 3, 4. Why have I not drawn it there? There you go. God grief. Right, so there's 6 carbons and there's no start and no end. They're connected in a ring. And what they do with those extra electrons is they make this delocalized ring. So that changes some of its properties, because it's this ring structure, means it's much more kind of stable. And it got this delocalized electrons, a bit like what we did in metals, that provided this extra kind of ring. Right, now we do our functional groups. So functional groups are just things that we can be popped on, popped off, change what it is. This is the whole basis of kind of Breaking Bad, making drugs, like actual proper drugs, developing banks. Like there would be lots and lots of stuff where we are just doing this. They're making things, they're making sense, like we did last year. By taking things and adding things, you're going to replace things to make plastics different. You're going to change fuels by changing these things. So we're going to do that a bit later, look at how we change them and the different pathways we can make them. So that is our functional groups, our little bits that we can end. So we're going to start with the one of the easiest. Right, so haloalkanes. Any of these could just have a halogen group on. So it's just taking one of our hydrogens and just adding a little fluorine or chlorine and adding onto that end. So it's just taking off a hydrogen, and adding one of those halogens to that group. Next one is going to be, and I'm doing this list as it comes in the in study design. So the next one is our amines with an N. So amines from amino. Oh, that line's terrible. Sorry. Stretch across like that. That's weird. That doesn't recognise that. There you go. Right. Amine with an N. We've got this R, which is rest of the molecule. This could be, not infinitely large, but this could be a large, too big, tangled, lots of carbon, lots of other things coming off with this on it. So that's our amine with an N. Then we have amide. I'm sure they were thinking about torturing us when they come up with some of these names. So that is similar, but it means we have an oxygen group in there as well. So we would have our R, which is our rest of the molecule. We have a carbon, and you are kind of assuming this R is a carbon, otherwise what are we talking about? But there's lots of other things coming this side. So R attached to a carbon. There's a double bond here with an oxygen, and then there's a nitrogen. Oh God. So a nitrogen can form 3 bonds. So there would be that one's wrong. It's wrong. So there's a nitrogen, H, and a 2. So there's 2 hydrogens here, and then this carbon is here. 1, 2, 3, 4. 4 bonds. So that's amide. Next ones are alcohols. So alcohols, hopefully you remember, it's got an OH on it somewhere. We're going to look at primary, secondary, and tertiary alcohols. So 3 different types. I do not think they do anything different to making you drunk, but don't drink them. Only drink things that you should drink. Right, so primary alcohol. Symbol for primary is a 1 with a little 0 thing up here. Oh my God, the light's getting worse. Right. There you go. Right, primary alcohol means that we have oh my God, that's a mess. Right. I'll scan in my book will make our lives easier. Right, primary alcohol means that we have our alcohol group linked to just the one carbon. So it's here, carbon is here, everything else around it is not a carbon. Because otherwise. So, they could be carbons, I suppose. No, can't be carbons. So there's our primary. It's on the end, sitting there, having adventures on its end. That's going to make difference when it comes with reactions and things, because it's going to be much easier for things to react with it than if it was elsewhere. Secondary alcohol we'll do next. So secondary alcohol means that our alcohol group, so this OH, is linked to 2 carbons. Yeah, 2 carbons. So it's linked in here. So it's kind of surrounded, and it's got carbons either side of it like that. So there, and we've got these 2 either side, which means that our alcohol tertiary would be is linked in with 3 carbons. So there's a carbon up here, and then so it's branching off at the same as this alcohol is coming off. Oh my God. So it's branching off at the same degree as our alcohol is. My writing is so wonky. Next one, aldehydes. I know it feels like a whistle stop tour. We're going to do the naming next lesson, so we'll get through these. There's a lot, but once you've used them a bit, hopefully you'll get a bit more comfortable with them. It's just a boring remembering kind of name. So you have to keep counting my bonds to check I've got it right. Right, aldehydes. These are when we have a carbon, it's got a double bonded oxygen and a hydrogen on that end, and very closely linked to these we have ketones. Ketones improve health, something we give off when we are trying to burn fat, I think, if I remember rightly. From when my personal trainery guy was nagging at me about something. Right, and ketones are similar, but we don't have this, so we can think of that being here or here. We're not going to have that hydrogen on there. So we've got our carbon double bonded to an oxygen, and then we've got two other groups that aren't just a hydrogen on this. So those are gonna not necessarily going to be at the end, because this could kind of be branching up here and branching up here, but you can also kind of thinking as a terminating kind of area, because it's going to change the properties of it. Carboxylic acid. So carboxylic acids, these are linked in with these as well. That's going to go back up here. I should do this at school where I actually can do it properly. It's a nice big whiteboard rather than a stupid thing I'm holding and waggling in the light. Right. Carboxylic acids. Right. Try and be good with the R's. So carboxylic acids means we have a carbon attached to another carbon with a double bonded oxygen and a hydrogen here. And my final one, which I'm going to spell wrong, and I'm very sorry for all of my bad spelling here, is the one named after one of our favourite people. I'm going to pretend it's named after you, Esther, and they didn't know how to spell it. So esters are where you get to an alcohol and a carboxylic acid and you kind of put them together. If we did it, remember we did it last year and we made those smells, some of them more successfully than others, but yeah, chemistry. So that's where we have a double bonded oxygen to our carbon, and then there's another oxygen with a rest here. So we've got a big chunk of something here and then a chunk of something here. So that's all what we're going to do now. What we're going to do with this lesson, I'm going to give you some lovely things to draw and to convert from our different structural forms, just to get you used to them and just to get those little bits in your brain going back where they need to be. But we're going to be fine. I'm confident with where we are. It's all good.